So, today we're going to continue talking about angles and their relationships to arcs. So far, when we've talked about angles and their relationships to arcs, we've talked about central angles and how a central angle is equivalent to the measure of its corresponding arc. But today we get to talk about different types of angles. Angles are not always going to be at the center of the circle. If they are at the center of the circle, that's a central angle, but sometimes they're going to be on the edge of the circle, which is called an inscribed angle. Now, inscribed angles also have their corresponding arcs, but those corresponding arcs have an actual name. They're called intercepted arcs. Much like with central angles. Central angles, one of the things I talked about is the central angle and its corresponding arc kind of make a pie slice. It's similar in idea with inscribed angles. I've got my angle here, angle 1. This there is its intercepted arc. It kind of creates that pie slice again, but it's for that person who's like, you get one piece, and it must be an acute angle. Yes, when you cut up pie, people definitely talk about making acute angles and not obtuse angles.
They can make them obtuse angles.
Although I really like it.
But so this is the intercepted arc specifically for angle 1. Now, central angles ended up having the exact same measure as the arc itself. Inscribed angles don't. Okay, I'm pulling out an invisible sticky note because I want this to show up on the recording. That's why I'm not writing it on the screen, but I don't want you to actually write this down. If I had the central angle for this specific arc, that central angle would be right here. Is that angle, we'll call it angle 2, is it an acute or an obtuse angle? It is obtuse. What about angle 1? Is it acute or obtuse? Acute. My point is, the same rule does not apply for central angles as inscribed angles. Inscribed angles are not equivalent to the measure of the arc. This arc, if I'm just estimating, is probably about 140 degrees. Because this angle appears to be about 140 degrees. But this arc, or this angle, is less than 90 degrees. It's acute. In fact, if that was a 140 degree arc, this angle would have been 70 degrees. How are 140 and 70 related? If I had a 140 degree arc, it's in, I don't know why I did T. Inscribed angle would have been 70 degrees. If I had a 200 degree arc, the inner inscribed angle would have been 100 degrees. If I had a 150 degree arc, the inscribed angle would have been 75 degrees. If I had a 100-degree arc, the inscribed angle would have been 50 degrees. What is the relationship? It's half of it. That is what the measure of the inscribed angle theorem tells us. It says that if you have an angle that is inscribed, then that angle is half the measure of its intercepted arc. So if angle ADB is the inscribed angle with AB its intercepted arc, then the measure of angle ADB is equal to 1/2 the measure of the arc AB. What's between 1/2 and measure of arc AB? What symbol? Times. Multiplication. So, if I want to go from knowing an arc to getting an angle, I divide it in half. What if I wanted to go the other direction? Multiply by 2. If I have the angle, I double it to get the arc. Okay, so questions we are asked here. I am first looking for the measure of arc TV. Start at T, end at V. Am I going the short way or the long way? Short way. I see an angle here. Is it a central angle or an inscribed angle? Inscribed, which means it is the same or half of the arc. Half. If you wanted to write the equation, you could write that 38 is equal to 1/2 times the measure of arc TV. Do you have to do that? Absolutely no. Because if you know the angle and you want the arc, you can do this by just getting rid of the 1/2. How do you get rid of times 1/2? Dividing by 1/2, you would have to use parentheses, or more easily, multiply by 2. The measure of the arc TV is equal to 76 degrees. If you have the angle to get to the arc, you can simply double it. Okay. Next one looks for the measure of angle G. Looking for that angle. Is that an inscribed angle or a central angle? Inscribed. Now the other thing you have to look at is the information you know actually corresponding to one another. This angle did go with this arc on question A. Does this angle go with that arc? Yes. So, the angle is what compared to the arc? Half of it. Again, if you want to do the equation, you can. Angle equals 1/2 times, and this time our arc was 90 degrees. You could do the formula if you want. Or, if you know the angle is half the arc, what's half of 90? 45. When it's just plain numbers, you can just say, okay, this is how I get that. Next problem. I want the measure of angle RTS. Okay, there's R, there's T, there's S. T is the vertex. Go towards R, go towards S. I want that angle. And I want the arc TQ. Start at T, end at Q. Short way or long way? Short way, because it's only 2 letters. Which one are you going to find first? It doesn't matter. You just got to make a choice.
Let's go in order, RTS.
Let's go in order. RTS. Measure of angle RTS. Do I half it to get the angle, or do I double it to get the angle?
I would double it. Actually, no, it would be half.
It's half. Measure of the... In case you've never heard me call it, this is Bugsy. Sorry. Yes. 24 degrees. I also want the measure of arc TQ. In the equation, key thing. Angle equals 1/2 times arc. You got to make sure you're putting things in the right spot in that equation. So, this time, when I'm working with finding the arc TQ, do I know its corresponding angle? Do I know the angle that goes with that arc? Yes. The angle is 50. So, in the equation, angle equals 1/2 times arc. If we don't know the arc, we can put an X or we can put the actual notation. I don't care which way you do it. Just change it back to actual notation if you do use X. Isn't it? How do I get the measure of TQ alone? Times by 2. If you know the angle, you multiply by 2 to get the arc. The measure of TQ is 100, also degrees. Two more that look like this, and then we're going to get to some that actually do a little bit more solviness. Yes, technical terms. Solviness. Charlie, you still with us? Mm-hmm. You sure? Mm-hmm. Okay. Next thing I'm looking for is the measure of angle HJL. J is the vertex. Remember, middle letter is the vertex of an angle. The other 2 letters tell you what sides to go on. Go towards H, go towards L. Do you notice that we don't know a single arc in this problem? No? Hey, guess what? We don't know a single arc in this problem. The 109 is an angle. That there happens to be an inscribed angle, the one we're looking for. Is that an inscribed angle?
Yes.
Yes. Okay, so let's do a little bit of highlighting. This angle's intercepted arc goes from H to L all the way around. The other angle that we're given is this angle here. Also an inscribed angle. Its arc goes from here to here all the way around. Wait a second. Wait 1 second. Do those 2 inscribed angles have the same arc? Yes. Start at H, end at L, go through M along the way. So, I can use that relationship.
I'm thinking of buckle or something.
Yeah. If I have an angle, do I cut it in half to get the arc, or do I double it to get the arc? would double it. And if you're not 100% sure, you could always go back to the formula that says angle, and I'm working with the green right now, equals 1/2 times, I'm going to call that x. For the sake of ease, let's move to an x. And yes, to get rid of a times 1/2, you multiply by 2. You're multiplying by the reciprocal. X, in other words, this arc, is going to be 218 degrees. Is that what I wanted? No. I wanted an angle. An angle that happens to have the same arc. So now I know how to work with the orange. I can say the measure of my angle, which I'm going to go back to HJL now. I put X here because that wasn't what I was trying to solve for in the first place, so I just kind of used it as a placeholder for something I needed. That angle is equal to 1/2 times its corresponding arc, which we just found to be 218. Half of 218. 109. Make sure sound's off on our phones, please. Notice anything interesting? We started with the same number. If an inscribed angle is half the measure of its arc, and two inscribed angles have the same arc, they're going to be the same. If you have the same intercepted arc for inscribed angles, that means the angles are going to be equal. Last problem on this page wants me to find arc RS and the measure of angle STR. Let's start with the angle STR. That's that angle. One of the things you're going to have to ask yourself is that an inscribed angle or is that a central angle? That's going to be a key as we go throughout this chapter. I'm not mixing it up a whole lot right now. Today it's been inscribed angles. Would you agree that that's also an inscribed angle? It's on the edge of the circle, is it not?
It is.
It's inside the circle, but it's on its edge. Therefore, its measure is half of its intercepted arc, which is this intercepted arc. I don't know that intercepted arc, but I do know this other angle here. Happens to have the same intercepted arc. If those two angles have the same intercepted arc, what did we just say is going to be true about them?
They're the same.
They are the same. The measure of angle STR is going to be equal to
SUR.
true, but not what I was looking to write. What is the measure of angle SUR?
Oh.
31. You're not wrong, Colin. It is equal to the measure of angle SUR. last thing it asked about was the arc RS. Starting at R, ending at S. Yeah, that's correct. Arc for that. Do I double to get the arc, or do I have to get the arc? Heard one person say double. Do you agree with her?
I'll bite half.
Now we got a debate going on.
I'll vote. I don't know.
Double or half? Who says double? Hands raised. About 3 people. Who says half? Hands raised. 1. There are more than 4 people in this class.
I don't think so.
Jeez, guys, get some participation.
Okay, let's try this again, and everyone must participate. Otherwise, we're going to spend the entire time working on this one problem, and you're going to get no work time because people didn't vote. Okay, the question again, if you missed it. To go from angle to arc, my question was, do you double or do you half it? Do you multiply by 2 or divide by 2?
Oh, I know.
Who says double? Hands raised. Who says half?
I swear if it's half, I'm gonna fall.
If you use the equation, it would say the angle equals 1/2 times the arc. How do I get the arc alone? U times by 2. Does that mean to double or does that mean to half? It means to double. You were correct if you said double. We gotta flip the page once you got this. Now, knowing that you double, knowing that you half, can make life a lot easier on problems that are just numbers like this page. But on problems that have an equation or an expression involved in the angles and the arcs, it becomes a little bit more necessary that we actually use the equation that we built. In that equation, I gave you this kind of simpler version that said when you have an inscribed angle, the equation said angle equals 1/2 times arc. Now, I don't write the equation this way originally because this ignores the fact that it has to be the correct angle and the correct arc corresponding. If they don't go together, you've got a problem. The question is, do they make a funky pie slice? If they don't make a funky pie slice, a greedy pie slice, then it doesn't work. Inscribed angle. Yes, that angle is on the edge of the circle. That's the angle that I'm given. This is the arc that I'm given. Do they create the funky pie slice?
Yes.
Yes. Those are corresponding parts. Those are the inscribed angle and its corresponding intercepted arc. Equation says angle equals 1/2 times arc. What part of this is the angle? Someone other than the 3 people who have been answering my questions all day. Yes, it's the 95. Equals 1/2 times What's the arc part? 14x plus 22. Sorry, I wasn't calling it a name quite yet. If you write it like this, there's one problem. It's not quite right. Doesn't need parentheses. The parentheses here are purely there to hold on to the degree symbol. So typically, we don't always need to put those parentheses actually into the equation. The exception is if there is something happening to where you're putting it. For example, if you're multiplying something by where you put it, it does need parentheses. So I have the equation 95 equals 1/2, and in parentheses 14x plus 22. Trey, if I want to solve an equation like this, what would you do first? Yes. When you've got parentheses and there's something multiplied by it, you have to distribute. So 95 I'm leaving alone equals 1/2 times 14x. Nobody's home. Call back never. This is Miss Benson. Yep, we're finishing up notes, so maybe about 10 minutes, 15 minutes. Perfect. Thank you. Bye. 1/2 times 14? 7. X. 1/2 times 22? 11. Don't forget the plus sign. That looks nicer. I know how to solve that. I divide by 7.
No.
Subtract the 11. Sometimes I say things just to see if you're paying attention. 84 equals 7x. Divide by 7. X is 12. Is that what the question asked me to do?
Solve for variables.
Good. Problem B. First off, double check what type of angle it is. Is that an inscribed angle or a central angle? Inscribed, it's on the edge. Okay, inscribed angles need their correct arcs. Okay, angly. That should be the angle's arc. Are those the right parts? Are they matched up correctly? Yes. Okay, so I want to write an equation. Inscribed angles. That's my general setup. I start with the angle. Brody, what is the angle? You got it. Equals 1/2 times. Lily, what is the arc? Beautiful. Isabel. I'll come back to you. Aiden. What do I do? Distribute. Jocelyn, what do I get when I distribute? Beautiful. Haley. Now what? We can subtract the 17 next. Not my favorite mood, but it works. Left with 5x equals 7x. What is negative 3 minus 17? Yes, negative 20. Be careful with your positives and negatives. Kylie, now what? But it's a positive 7. Subtract the 7. Gotta be careful with our adding and subtracting. This is a common mistake that I see people deal with when they get something like 7x minus 20. That minus is stuck on the 20, not on the 7. So we subtract the 7, and the 20 is still negative. BG, how do I finish? 5 by negative 2. Negative divided by a negative. Positive 10. Beautiful. I love it. Good thing I drew your name next.
Yay.
Question C. What's the equation going to look like?
9x minus 3 equals 1/2, and in parentheses 16x plus 8.
So from what I understand, you are telling me that this is an inscribed angle and this is its corresponding arc then?
Yes.
Yes. I agree with you wholeheartedly. Jasmine? Now what? Distribute. Greta, what do we get when we distribute?
1/2 times 6. 8.
Mm-hmm. And 1/2 times 8?
4.
Keep an eye on positives and negatives. This one happens to be a plus, sometimes it could be a minus. Keep an eye on that when you distribute. Then we're solving. I would move x's together first. Saves some headaches sometimes. X minus 3 is equal to a positive 4. Add 3 and x is 7. We have one final problem here. But this problem's a little different. Seems
That looks funky, Miss Benson.
It does look funky. It's got a lot going on. So I try to break it down a little bit further. Okay, I see this here is one of the things I know. It is an inscribed angle. I see the other thing that I know is this thing. It is also an inscribed angle. Do you notice that the ends of those angles are the exact same points? Implying that this right here is a shared intercepted arc. When they share an intercepted arc, what does that mean about the angles? That they're going to be the same. They're equal. 12x minus 13 is equal to 9x plus 2. And then we solve. I'm just gonna quickly solve because I know you know how to solve, save for we make a couple of mistakes every once in a while. As do I.